The potentially catastrophic climate change risk that will be discussed in this video exemplifies the considerable differences between scientific and societal or business risk assessment frameworks to evaluate the exposure of society to unacceptable consequences. In 2013, the BBC published an article about the research of Anton Vax et al. It concerned a cave in Siberia. The scientific research concluded that at a mean planetary temperature increase of 1.5 degrees centigrade, there was a rapid melting of the permafrost. This image shows the consequence, and anyone who understands how calcite formations normally grow in caves or potholes will rightfully be shocked. In 2021, the NOAA Arctic Report Card included a section that should have alarmed anyone who comprehends the full implications. That section stated that at a mean planetary increase of 1.5 degrees centigrade, weather patterns in the Arctic would more than likely change from snow to rain. That helps to explain the prior image. To understand the implications, let us start by understanding why rain in the Arctic could be catastrophic. The energy in rain has two components. One is its temperature, and the other is the latent heat it contains. The temperature energy is 1 calorie per cubic centimeter per degree. The latent heat it contains is 80 calories per cubic centimeter. And that is enough energy to raise the temperature of 1 cc of water from 0 to 80 degrees centigrade. The Arctic Report Card was compiled by 111 scientists from 12 countries, and to underpin their assertion that it would rain in the Arctic at a 1.5 degrees centigrade increase, they cited the fact that in 2021, at just over an increase of 1 degree centigrade, it rained on the summit of Greenland. That's at 10,000 feet, or just over 3,000 meters, and that area of Greenland is in the Arctic Circle. The temperature was 0.48 of a degree centigrade. The duration was 3 days. The estimated quantity of rain was 6.3 giga or billion tons. Due to the latent heat, this was the equivalent energy of exploding 31,500 Hiroshima bombs in just 3 days on the summit of Greenland. The consequence was that the ice melted 7 times faster than would be anticipated at that time of the year, and the multiple knock-on societal risks deserve a dedicated video. It is the pristine nature of snow that dominates the albedo effect in the Arctic. When the surface is pure snow, it reflects 85 to 90% of the incoming solar energy back to space. But when the snow melts, forming melt ponds, the resulting darker water only reflects 10 to 15%. This is critical because changing the ability of the Arctic to reflect incoming energy back to space has immense implications. This is a typical example of melt ponds forming as snow melts, in this case on the sea ice. And as the situation has already progressed, on the tundra, as the Arctic temperature continues to increase, the Arctic has flipped from a sink to a source of greenhouse gases. In 2019, scientists established that the Arctic emitted the equivalent of 2.31 gigatons of CO2. That alone exceeds and thus negates a stated annual objective of COP26 to reduce emissions 45% by 2030. If one adds the increase in the atmospheric content of methane and nitrous oxide, some of which originated from the Arctic, it is abundantly clear the objective cannot be met. As with the tundra, there are considerable changes to the Arctic sea ice. It has been established that when melt ponds form on the ice at the start of the melt season, the result is a near or record low at the end. An event or series of events, similar to the one that occurred on the summit of Greenland, would more than likely have a catastrophic impact on the sea ice, and the area of the sea ice influences the weather patterns of the northern hemisphere and thus the world's food supply. There are an estimated 1,400 gigatons of carbon constrained in the tundra. That's not carbon dioxide, it's carbon. And 1,400 gigatons of carbon in the form of methane in the East Siberian Arctic shelf, which resides under the Arctic Ocean. A tiny fraction of these amounts released in any given year would more than likely rapidly propel the climate change to a rate beyond the ability of humanity to control, and would be irreversible well beyond human lifetimes. The planet is a chunk of rock with a molten core orbiting a star, and has gone through many changes since it formed, the vast majority of which would have been inhospitable for our species. The overarching question is, how are we going to ensure that the planet remains hospitable for our species? One identifiable risk is a semi or persistent world food crisis, as weather patterns change due to events in the Arctic. The potential minimum consequences are resource wars, the possible implosion of the financial system due to OTC derivatives, and worldwide societal chaos. Another is an ever-increasing rate of change of climate change beyond the ability of humanity to regain control. This would more than likely ultimately lead to the collapse of our civilizations and an unthinkable contraction of the world's population. With respect to the timing, it should be clear that these events are in their early stages, and the analysis of data indicates that a breach of the critical temperature of 1.5 degrees centigrade will be by or before 2030. Note that climate change is in a nonlinear or accelerating mode. Therefore, we are literally hurtling towards these risks faster day by day. Irrespective of the reticence to act, due to ongoing environmental changes releasing ever-increasing quantities of greenhouse gases, no amount of emissions reductions that could be remotely possible to implement in the time available will impact the outcome beyond the slightest delay. The only viable response to this rapidly deteriorating situation is to intervene and cool the Arctic as soon as possible. Intervention, also known as geoengineering, is contentious. The foregoing presentation outlines the plausible worst-case scenarios for which we are ill-prepared, and they unquestionably expose humanity to levels of risk no military, business, or responsible parent would undertake in any other situation, and yet that is precisely what we are doing. The reality is that all assets, lifestyles, even families, particularly children, are at ever-increasing, untenable levels of risk akin to those experienced in a casino, even in the short term. The issues discussed in this video are not included in AR6, and it is unlikely they will be included in AR7 anywhere close to the manner of this video, that is, with the interrelated consequences highlighted. This is the fundamental reason all sectors of society must conduct due diligence to augment IPCC data in order to discover the actual risk profiles they face by developing an applicable risk assessment framework conducive to their responsibilities or obligations. In many cases, for instance corporations, institutional investors, and the majority of financial institutions, a failure to accomplish this is a clear violation of fiduciary responsibilities.